Hey everyone, welcome back and let's solve LeetCode 724, find pivot index today on DKodeTree. The ask in this problem is very simple, just to return the pivot index if it exists. Now the pivot is a very generic term and its definition can vary from context to context. Suppose this is the array. In this problem they have mentioned the pivot index is the index of an element for which the sum of all the elements to the left of it is equal to the sum of all the elements to the right of it, and the number itself is not included in any of the sums. Now the most intuitive way to solve this problem is to take each index and check if it is the pivot or not. Note that there can be more than one index satisfying the given condition, but we have to find the leftmost pivot index. So let's start checking from the left end, that is, index 0 is pivot or not. For this we have to calculate two things. One is the left sum and next is the right sum. Left sum is the sum of all the numbers to the left of the current index, which in this case is 0. And right sum is the sum of all the elements to the right of the current index, which is 7 plus 3 plus 6 plus 5 plus 6 equal to 27. Now as 0, the left sum is not equal to 27, the right sum. So 0th index is not the pivot index. Next we will check for index 1. Now the left sum is 1 and the right sum is 3 plus 6 plus 5 plus 6, which is equal to 20, which again does not match. That is, the left sum 1 is not equal to the right sum 20. So 1 is also not the pivot index. Similarly, we will check for each of the other indices. But notice that in this approach, for each element, we have to calculate the left sum and the right sum repeatedly. And calculating the sum itself takes O of n time. And there are n such elements for which we may need to do this process. So the effective time complexity becomes O of n square, which is not very efficient in this case. But can we do better than this? It turns out that we can cut down on some repeated work while calculating the sum. Note that as we move through the array, the left sum increases and the right sum decreases. So what if we calculate the sum incrementally on the go? This we can do using a very interesting but simple technique called prefix computation, or prefix sum in this case. So now let's calculate the left and right sum on the go. So we will start checking from index 0. So initially our left sum, which is the prefix sum, will be 0. And what will be the right sum? If you notice, the right sum is actually the total sum minus the left sum minus the current number. We need to separately subtract the current element as it is not included in the left sum. So let's do the total initially. In this case, the total is 28. So we will calculate the total only once initially, which will take O of n time. But we will be calculating the left sum and the right sum on the go in constant time. So even if we calculate it for all the n elements, the total time complexity will only be O of n. Now let's calculate the right sum. So total is 28 minus the left sum, which is currently 0, and minus the current element, that is 1, which comes down to 27. Now as we can see that the left sum and right sum are not equal, so we know that index 0 is not the pivot, and we can move to the next index for checking. But before moving to the next index, we will update our left sum, because now the left sum for the next index will include the current number as well. So that will come to 0 plus 1, which is equal to 1. Now we are at index 1 and our left sum is already updated. Now we will calculate our right sum, which this time is total, that is 28, minus the left sum minus the current element. So 28 minus 1 minus 7, which comes down to 20. Now again the left sum and right sum does not match. So 1 is also not the pivot index. Now before moving to the index 2, we will again update our left sum by adding the current number, which comes down to 1 plus 7 is equal to 8. So now we are moving to index 2. Our left sum is already updated. Now let's calculate the right sum, which will be equal to 28 minus the left sum 8 minus the current element 3, and this comes down to 17. But still the left sum is not equal to the right sum. So index 2 is also not the pivot. Now before moving to the third index, we will update the left sum again, that is adding the current element to the left sum. So 8 plus 3 becomes 11. Now we have moved to the third index and we have already calculated our left sum. Now let's calculate our right sum as well, which comes down to 28 minus the left sum, that is 11, minus the current element, which is 6, which comes down to 11 as well. Now we can see that our left sum matches the right sum. This implies that we have found our pivot index. As this is the first or the leftmost index for which our left and right sum matches, so we will return 3 as the result. Now suppose even after iterating through the entire array, we do not find a pivot index, then we will return -1. We are calculating the left sum and the right sum incrementally on the go. So the summation itself is working in constant time for each element. But as in the worst case, we may need to go through every element in the array. So the time complexity of this approach is O of n, which is way better than the previous approach. Also, as we are using only two integers for the left and right sum, which takes only constant amount of space, so the memory complexity is O of 1. Now let's code this approach. So first of all, we will calculate the total sum, which will be calculated only once and takes O of n time. Next, we will define our variable for the left sum and initialize it to 0. Now we will go through each element in the array one by one. For index, number in enumerate nums. Using the enumerate function, we can go through the index and the element of an array at the same time. Now we already have our left sum. We will calculate our right sum. Right sum is equal to total minus the left sum minus the current number. Now we have got our left sum and right sum both. We will just check if the left sum and the right sum matches or not. If the left sum matches the right sum, then we will simply return the current index as the pivot index. But if we haven't found our pivot index yet, then we will continue the loop and update our left sum. So left sum plus is equal to the current number. By this, we are adding the current number to the left sum. This simply means left sum is equal to left sum plus the current number. Now, even after going through the entire array, if we haven't found our pivot index, we will simply return -1. So this was all the code needed to solve this problem. Now let's run this and check if it works. We can see that this works fine and is quite efficient. If you found this helpful, do hit that like button and subscribe to DKodeTree. This supports the channel a lot. And if you have any queries, let me know in the comment section. Thanks for watching. See you in the next video.